known as force. Now, if we apply a force on the ball, then it can move. The answer is it will not move. So, sometimes force can move a stationary object, or sometimes it cannot move, but it tries to move a stationary body. Now, this is an object. If I leave this object from some height, then it starts motion in downward direction. If we apply a force on it, then we can stop its motion. But if we apply the force on a fast moving car, can we stop it? No, we cannot stop it, but we try to stop the car. So we can say that sometimes force can stop a moving body, or sometimes it tries to stop a moving body. So we can define the force as force is a push or pull which can change or tends to change. Either it will change or it will try to change, which can change or tends to change the state of rest or state of motion of a body. If we apply a force on a body, it has a particular direction. In which direction we are applying the force? So that force is a vector quantity. Force is represented by F. When we apply a force on a body, can we measure it? Yes, we can measure it. When we apply some force on a body, then it increases the speed of a body or decreases the speed of the body. We can say that when we apply a force on a body, it produces an acceleration. So, force acting on a body is equals to the product of mass of the body and acceleration produced in it, or F equals to M into A. The SI unit of force is Newton. Now we will discuss the effects of force. As we have discussed, force can move a stationary body or try to move a stationary body. So first effect is force can move or tends to move a stationary body. Force can stop or tends to stop a moving body. Some other effects also there of force. In a cricket match, when bowler threw the ball towards batsman, then batsman hits the ball and applies a force on the ball with the help of bat. Then what happens? Batsman changes the direction of the ball as well as the speed of the ball. So we can say that force can change the direction of motion, or force can change the velocity of a moving body. This is a rubber band. If we stretch it, then its size increases. But if we stretch a rigid body, then can we change its size? No, we cannot change its size. So force can change or tends to change the size of a body. If we apply the force on this bottle, then what happens? Its shape changes. But if we apply the force on a rigid body, like as this marker, then what happens? Can we change its shape? With the help of force, we cannot change its shape, but we try to change the shape. So we can say that force can change or tends to change the shape of a body. If more than one force is acting on a body, like as force F1 and F2 are acting towards right and F3 is acting towards left, there are three forces acting on a body, then the sum of all these forces is known as resultant force. If the total force acting on the body is F, then F equals to F1 plus F2 plus F3. If F1 is 10 Newton, F2 is 15 Newton and F3 is 8 Newton, then how much force is acting on the body and in which direction it is acting? We can find the sum of all forces as 10 Newton and 15 Newton are towards right, so they will be positive. And force F3 is acting towards left, so it would be negative. And the sum of all three forces is 17 Newton and it would be acting towards right. Our next topic is balanced force. If there are more than one force is acting on a body, like as F1, F2 and F3, and the sum of all forces or the resultant force is 0, then we can say that the forces are balanced. Like as F1 is 5 Newton, F2 is 6 Newton and F3 is 11 Newton. Then what would be its resultant force? The resultant force F would be equals to F1 plus F2 plus F3. As F1 and F2 are towards right, so they would be positive, and F equals to 5 plus 6 and F3 is towards left, so it would be negative, and the sum of all three forces would be 0. So we can say that the resultant force acting on this body is 0, or the all forces are balanced force. So we can define the balanced force as if the sum of all forces acting on a body or the resultant force acting on a body is 0, then the forces are known as balanced force. If the forces are balanced, then body will move? No, body will not move, because the resultant force, the sum of all forces is 0. So there is no effect of force. When we push a ball with a force F1, then we also experience an opposite force. Let this opposite force be F2. Since ball is not moving, so we can say that the force applied by us F1 and force applied by the ball in opposite direction, both are equal to each other, but both are opposite in direction, so one force is negative, and we got F1 plus F2 is 0. Since the sum of both forces F1 and F2, force applied by us and force applied by ball, is 0, so we can say that the forces are balanced. In tug of war, both teams applies the force. The left team applies the force in left direction and right team applies the force in right direction. Initially, when they applies the force, rope will not move in any direction. we can say that the force applied by the left team F1 is equal to the force applied by the right team F2, but both teams are applying the force in opposite direction, so F1 is equals to minus F2 and F1 plus F2 equals to 0. Since the sum of forces applied by the both teams is 0, so we can say that the forces are balanced. Now next topic is unbalanced force. If the resultant of all forces acting on a body is not equal to 0, then the forces are known as unbalanced force. Like as there are two forces acting on this box. One force is F1, another is F2. If F1 is 10 Newton and F2 is 8 Newton, then what would be the sum of these forces? Then the sum of these forces F equals to F1 plus F2. As F1 is towards the right, so it would be positive, and F2 is towards left, so it would be negative, and the sum of these forces is 2 Newton. This is not equal to 0. So we can say that these forces are unbalanced force. If a bicycle rider stops pedaling, then what happens? The bicycle slows down. Why? Why it slows down? Because when rider stops pedaling, then there is no forward force acting on the bicycle, but there is a force acting between the tires and the surface of the earth in opposite direction of motion, that is known as friction force, which slows down the bicycle. If rider again starts pedaling, then exerts force F1 by pedaling on the bicycle in forward direction, and F2 is the force of friction in opposite direction of motion. Then three conditions arises. The first condition is F1 means force exerted by the rider is greater than the force F2. Like if force F1 is 10 Newton, then force F2, force of friction, must be less than force F1. We assume that it is 8 Newton. So the resultant force is 10 Newton minus 8 Newton, that is equals to 2 Newton, and it is greater than 0. Since the resultant force is greater than 0, so the speed of the bicycle increases. If F1 is less than F2, as we have assumed that F2 is 8 Newton and F1 is less than F2, so F1 may be 6 Newton, 5 Newton or 4 Newton, then what would be the resultant force? Forward force is 6 Newton and the force in opposite direction of motion is 8 Newton, and it would be negative since its direction is opposite to the direction of motion. So it would be minus 2 Newton, and minus 2 Newton is less than 0. If the resultant force is negative or less than 0, then the speed of the bicycle decreases. Now third condition is if F1 is equal to F2, means F1 is of 8 Newton and F2 is of 8 Newton, but both forces are acting in opposite direction, so the sum of these forces would be equals to 0 Newton, means there is no effect of the forces. If the bicycle is at rest, then it remain at rest. If the bicycle is in uniform motion, then it will continue its motion with the same speed. Now we will discuss the differences between balanced and unbalanced force. As we have discussed, in balanced condition, the sum of all forces acting on a body is always equal to 0. But in unbalanced condition, the sum of all forces acting on a body is not equal to 0. We can write it as, in the balanced force, the sum of all forces F1 plus F2 plus F3 and other many forces acting on the body, and the sum of these forces is equals to 0. But in unbalanced forces, the sum of all forces is not equal to 0. Balanced force cannot change the state of rest or state of motion of a body, but unbalanced force can change. So the next difference would be, balanced forces can't change the state of rest or state of motion of a body, and unbalanced forces can change the state of rest or state of motion of a body. Now we will discuss inertia. This is a football and it is at rest. Can it move without applying the force? No, it cannot move without applying the force. Have you ever think why it happens? Why it cannot move without applying the force? One more example is there. If the ball is in motion and there is no friction force, can it stop itself? No, it cannot stop itself. Why? Because every body has a property due to which it opposes any change in its state of motion or its state of rest. That property of the body is known as its inertia. So we can define the inertia as, it is the tendency of a body due to which it opposes any change in its state of rest or state of motion. Now there is a shopping trolley and it is empty. We can move it with a small force easily. But if we put some goods in it, then can we move it with the same force? No, we cannot move it with the same force. Why? Because its mass increases. So we need larger force to move this trolley. So we can say that the inertia of a body depends upon its mass. A body which has small mass has smaller inertia, and a body which has large mass has larger inertia. Or we can say that mass is the measure of inertia. Now we will discuss the types of inertia. Inertia is of three types: inertia of rest, inertia of motion, and inertia of direction. This is a glass and this is a card. First we will put this card on the glass. Then we will put a coin on the card and we flick the card. Then what happens? Card moves, but coin does not move. It falls inside the glass. Why it happens? Because when card starts motion, the coin was at rest and it opposes any change in its state of rest. When we flick the card, then card moves away and coin falls. When a bus suddenly starts, the passengers feels a backward jerk. Why? When bus starts motion, the lower part of the passengers starts motion with the bus, but the upper body part of the passengers wants to remain at rest. So the passengers feel a backward jerk due to inertia. When a carpet is beaten with a stick, then dust particles comes out. Why? When we beat a carpet with a stick, then it starts motion, but dust particles wants to remain at rest and separated from the carpet due to the inertia. So we can say that every body has a tendency to oppose any change in its state of rest. That is known as inertia of rest. So we can define the inertia of rest as, The tendency of a body to oppose any change in its state of rest is known as inertia of rest. Next type of inertia is inertia of motion. In a race, when the sprinters reaches to the finish line, they keep move for some distance. Why it happens? Because when they reaches at the finish line, they want to stop their body, but the body wants to continue the motion in the direction of motion. So it takes time to stop the body and they keep move for some distance. We tie the luggage at the roof of the buses with the help of a rope. Why we do like this? Because if we will not tie the luggage with a rope on the roof of the buses, then when the driver applies the brakes, then bus stops and luggage may fall in forward direction due to inertia of motion. If driver applies the brakes suddenly, then what we feel? If we are inside the bus, then we feel a forward jerk. Why it happens? Because when driver applies the brakes, then bus stops. But our body wants to move in the direction of motion and our upper body part move in the direction of motion. So we feel a forward jerk. We can say that every object has a property due to which it opposes any change in its state of motion, and that property of the object is known as inertia of motion. We can define the inertia of motion as the tendency of a body to oppose any change in its state of motion is known as inertia of motion. Now we will discuss inertia of direction. If we have a stone tied with a string and we are revolving it in a circular path and the string breaks suddenly, then what happens? If the string breaks suddenly, then it flies tangentially. Why it flies tangentially? Because when it revolves around the circular path, the string applies a force on it. But when the string breaks suddenly, then there is no force applied on it and it cannot change its direction by itself. So it moves tangentially. In rainy seasons, the water droplets and the mud particles stuck with the tires of the vehicle. When we move forward, then the water droplets move with the tires and flies tangentially. Why they fly tangentially? Because when they stuck with the tire and move in upward direction, then there is no force to change their direction. So the mud particles and water droplets fly tangentially. We can say that every object has a property due to which it opposes any change in its direction of motion, and that property of the object is known as inertia of direction. We can define the inertia of direction as the tendency of a body to oppose any change in its direction of motion is known as inertia of direction.